Welcome, and let's talk about SymmetroBloom 4B, a geometric model of 16 symmetries for final term project. So this is part 6 of our presentation and the last part. No? And again, I'm Jerry Abigail Bakay from BS Ed Math TA. So for our last task, investigate the left and right cosets of the different subgroups, normal subgroups, and coset groups isomorphic to Z sub n and other known group structures. So for this activity, I chose to focus on proper subgroups because if we use trivial subgroups, the cosets just repeat the whole group. And if we use the whole group, the factor group becomes too simple with only one element. But with proper subgroups, we can generate multiple distinct cosets, observe their structure, and check if the resulting factor groups are isomorphic to known groups, which directly supports the goal of this task. Let's proceed to B sub 5. So to get the left cosets of a subgroup, we multiply each element of G by every element of H, one representative at a time. We repeat the process using unused elements until we form all distinct sets. So to get A and R, the element A and R, we operate A on the elements of B sub 5. A star A, we get A, and then A star R, we get R. That's why we have this. Next, let's operate B on the left side of B sub 5. Now, B star A, we get B, and B star R, we get small a. Next, we have S. S star A is S, and S star R is small c. Next, let's have T. T star A is small t, and T star R is K. And just repeat the process to get these cosets or the left cosets of B sub 5. And as we can see, we have 8 distinct left cosets for B sub 5. Now let's explore the right cosets of B sub 5. In getting the right cosets of B sub 5, it is very similar to left cosets, but the group element is operated on the right instead of the left. Let me show you how it works. A star A is A, and then R star A is R. That's why we have A and R. Next, let's operate A star B is B, and then R star B is small a. That's how we get this. Now let's have S. A star S is S. That's why we have S here. And then R star S is small c. That's why we have small c here. So just repeat the process and we will get these right cosets. And as we can see, no, we have 8 distinct right cosets for B sub 5. Now, how will we know if B sub 5 is a normal subgroup? So if each left coset matches its corresponding right cosets, then H is a normal subgroup. So let's see. So this is the left cosets and this is the right cosets. And as we can see, the left cosets matches the right cosets. And so with that, B sub 5 or the subgroup B sub 5 having elements A and R is a normal subgroup. Now, the index of a subgroup tells us how many cosets it forms in the group. It's calculated by dividing the order of the group by the order of the subgroup. So for B sub 5, we have 8 cosets. Let's have another example. So for this, we just have to apply the same process in getting the left cosets. We just have to operate the elements, each element of the largest set on the left side of B sub 21. So A star A is A, that's why we have A here. And then A star S That's why we have S here. Then A star R is R. That's why we have R here. And then A star small c is small c. That's how we get the left cosets. So we just have to do the same process using the unused elements until we form all the distinct cosets. And for B sub 21, we have 4 distinct left cosets. Now let's explore the right cosets of B sub 21. So here it is. Instead of operating the elements of the largest set to the left side, we operate to the right side. And we have A here. Just operate it to A. A star A is A. And then S star A is S. That's why we have S here. And then R star A, we get R. That's why we have R here. And then small c star A is a small c. That's how we get this. Let's try operating B sub 21 to B. So A star B is B. That's why we have B here. And then S star B is a small t. That's why we have small t here. And then R star B is small a. That's why we have small a here. And then small and then small c is star B is k. That's why we have k here. So just simply repeat the process until we get all the distinct cosets. And as we can see here, we have 4 distinct right cosets for B sub 21. And to know if this B sub 21 is a normal subgroup, the left coset must match the corresponding right cosets. So, and as we can see, the left cosets matches the right cosets. That's why B sub 21 is a normal subgroup. And in getting the index of B sub 21 or the number of cosets for B sub 21, just simply divide the order of the largest group by the order of the subgroup B sub 21. So 16 divided 4 is 4. And that's how we get the index or the number of the cosets for B sub 21. So same process for B sub 22. Let's have this example. B star A is B, that's why we have B here. And then B star B is S, that's why we have S here. And then B star S is T, that's why we have T here. And then B star small t is R, that's why we have R. B star R is small a, that's why we have small a. And B star A is small c, that's why we have small c here. And then B star C is K, that's why we have K here. And then B star K is A, that's why we have A here. And that's how we get the left cosets. And just repeat the process until we get the distinct cosets for B sub 22. Now let's explore the right cosets for B sub 22. Just repeat the same process in getting the right cosets for B sub 22, and we will get these cosets. And to know if it is a normal subgroup, what we do is to compare, and if it matches, then it is a normal subgroup. Since the left cosets and the right cosets are the same, then we can conclude that B sub 22 is a normal subgroup. And to know the index or if this is correct, having 2 distinct cosets for left cosets and right cosets, we will check the index. So 16 divided by 8, since B sub 22 has 8 elements, we get 2, and it is correct. So the index of B sub 22 is 2. Now, among all the proper subgroups, these are the subgroups that is not a normal subgroup. Now, let's check their index. So since B sub 5, B sub 9 to 16 has two elements, then I 16 divided by 2 is 8. That's how we get the index. So the number of left cosets and right cosets for these subgroups is 8. And then the B sub 17 to B sub 21, since it contains or it has 4 elements, then 16 divided by 4 is 4, meaning these subgroups has 4 cosets for left and right cosets. And then for B sub 22 to 24, since it has an order of 8, then 16 divided by 8 is 2, meaning these subgroups has 2 distinct cosets for left and right. Now here are the normal subgroups. So we need to use the normal subgroups when forming factor groups because only normal subgroups guarantee that the set of cosets can follow the group rules. Now we have this. Since each of the B sub I is a normal subgroup of G equal 4B, then the factor groups are this. So these are the factor groups. Now, we need to know the order of a factor group because it tells us how many cosets are in each factor group. So B sub 21 has order of 16, or it has 16 cosets. And then for B sub 5, it has 2 elements, then it has 8 cosets. For B sub 21, it has 4 elements, that's why it has 8 cosets. And then for B sub 22, B sub 23, and B sub 24, it has or it contains 8 elements. That's why the order or the number of cosets of B sub 22, 23, and B sub 24 is 2. And then we have the group for B for the largest set, 16 divided by 16 is 1. So it only contains 1 coset. And that's it for this presentation. Thank you very much. God bless us.